Hello and welcome to Bits and Atoms, the Grisham Robotics Founder Series. I'm your host, Elias Can, and today I've got Adam Versteegh, co-founder and CEO of Inframesh, joining me. To get started, Adam, would you mind sharing a quick intro about you and Inframesh?
Of course. So I'm Adam Versteegh. I'm the founder and CEO of Inframesh. And since 2022, our mission has been to see energy clearly for the first time using advanced hardware and AI.
Awesome. Let's jump into some questions. So maybe a little more personal one to get started. What originally inspired or motivated you to take a leap to become a founder?
So what I really saw was there was a gap between what the research showed was possible in high-frequency, non-intrusive load monitoring and the existing products. So the technology could clearly do more, but it hadn't been built, perhaps due to perceived issues around the device size, cost, power consumption, and the processing demands required to make sense of the data. But with recent developments in AI, including transformer architecture introduced in 2017, and more recently new NPU chips, neural processing unit chips, and the ubiquity of ADCs, analog to digital converters, and other improvements in the supporting components, it became possible at this particular point in time to realize a fully capable system. So the evidence in front of me made it clear that this was the most impactful thing that I could be working on by a long way. And once I started working through those constraints, it became clear that there weren't really any downsides. And at that point, it stopped being optional. I just had to build it. So I've always been drawn to electronics, building electronics projects and tinkering, and seeing ideas turn into real systems. Growing up, was constantly experimenting. I was often interested in the problems that felt underexplored. I spent my summers in Sweden, where our neighbor was a carpenter and tinkerer who built his entire house from scratch himself, and even built his own car out of bike parts. And that made me realize that you can just build whatever you want, whatever you can dream up, you can build. And that's always excited me. And since then, I've always loved building things. So later on, I was mentored by leaders in high-end electronics, digital conversion, and signal processing, which set a clear benchmark for world-class products and inspired me to ultimately start my own electronics company in my own direction. When I looked at the existing products on the market, I felt that there was a whole layer was missing, the ability to remember each device as a distinct instance with its own states, conditions, behaviors, all linked together in a universal product solution. So the system only uses analog inputs, so there's no integration effort required. And working in commercial smart buildings, I saw many bespoke systems with a high cost and complexity. This is completely opposite. So the AI figures everything out from the clip-on sensors, only sensing the analog again. And the hardest part is that the value can sometimes seem abstract at first, and people often ask, does it control things? But my mission's never been about the control. It's always been about fully understanding energy signals. And from the property management perspective, the value is clear, but my focus has always been about fully solving that problem first.
Yeah, very interesting. And it sounds like a very technical problem. It sounds like you had some great exposure growing up to people that were great at solving technical problems. And so that was probably a nice inspiration and lead up for you to take that path yourself in terms of being a builder. I know you touched on this a little bit in the intro in terms of what you're building and in the market that you're in, but maybe to double click there a little bit, what would you say today are some of like the key pitfalls of energy monitoring solutions on the market, and how Inframesh is different from what's on the market today?
So the biggest issues are scalability and practicality. Most systems aren't truly plug and play, making them hard to install, expand, and maintain. That's particularly true for intrusive systems, which would never be commercially viable at scale anyway. Compared with existing meters and monitors, low frequency sampling, cloud-only processing, and limited insight means these products can't understand the real usage or come close to the full potential. They lack the intelligence, the AI at the edge, and much of the data collected is too slow to be useful, and a huge amount of value is simply lost because the signals aren't captured and processed properly.
Yep. Totally makes sense. And it's interesting because it's like a range of kind of like challenges, pitfalls, shortcomings of products on the market today. And so it leads into kind of an interesting question, I think, when you're meeting with potential clients, you're sharing what the Inframesh Supermeter does with them. Like, what do you feel on your side is the best value proposition for the product today? What's kind of like the aha moment for potential clients when you meet with them?
So the aha moment is when the clients see their blind spots for the first time. That's what they're telling me. So when they see what they're missing and they see the potential of the technology, that's what it was for me as well. So the Supermeter delivers the deep visibility without the friction. It's inexpensive, easy to install, no power consumption penalty, and scales cleanly. And it can identify the devices in seconds rather than weeks and months, and hundreds of devices per device. And it works in any building, regardless of size or complexity. So the AI is a genuinely useful, high-frequency, edge-based, and focused on real understanding, which seems like it should be impossible, rather than the surface-level aggregate metrics. And when the clients see that, the reaction is more like, why wouldn't you have this? What's been particularly interesting is how broad the pull has been. So we've seen strong interest from insurance, where the device level risk and behavioral patterns suddenly become visible in a way that wasn't possible before. In industrial settings, the ability to see everything at the device level, productivity, machine faults, delivers outsized value with minimal upfront outlay, especially for facilities that wouldn't normally adopt advanced manufacturing tech. So one example is a shoe factory we're piloting with in the UK. They run basic systems. They spend around £120,000 a year on electricity. And yeah, they wouldn't be the typical customer for complex industrial platforms. They're quite small. But the Supermeter ties everything together for them and makes their entire facility AI-driven with almost no integration effort. So it's a game changer. So we now have pilot sales lined up across homes, offices, factories, universities, spanning regions from the UK, Saudi Arabia, Estonia, Serbia, Poland, Qatar, and more. So our university partners are especially excited about the living laboratory aspect. So it gives them the real infrastructure to build their own AI on, and we collaborate with them directly on that work. And the challenge has been making something very advanced feel simple and obvious, and navigating that, and like any great consumer product, so people can trust it immediately, even if the underlying concepts are complicated.
Sounds amazing, and a no-brainer for potential clients to sign on. And no, really interesting to hear kind of the diverse set of use cases, especially across different customers in different industries, what they would value, how they see the product. Very interesting to hear about that. And maybe going in a little bit of a different direction, but still on the product side in general, I'm curious, what would you say has been the biggest hurdle or most unexpected challenge of building in hardware so far?
So time is definitely the biggest constraint. So designing and manufacturing a device with the high frequency digital and analog signals together, mixed signals in the small form factor, is inherently complex. Hasn't been done before in this way. As with any electronics, but especially with this design, there's no room for error. I've learned that the hardware many times. Sometimes with catastrophic results. But one impedance control in this instance, or layout misstep, can stop the entire system from working and set you back for months. So that's quite an exciting, interesting element, is the kind of impedance control, is kind of deep elements that we need to take into account. And the ambitious, no compromise hardware carries the real risks, and you either do it properly or you don't do it at all, in my view, and doing it properly takes time.
Absolutely. I think that's a common thread I've heard from other folks building in hardware, is that it takes time. There's definitely a certain amount of granularity that you have, and if there are issues, it's not like you can easily ship a software fix over the air or something like that, like you can with a pure play software product. It's a lot more intensive to fix an issue in hardware. And so it kind of comes back to that time factor as well, that everything just takes a bit more time and a bit more attention to detail at every step to make sure everything is right and well.
Yeah.
And maybe switching gears a little bit to chat about the fundraising side, because I'm curious, with such a unique product and space as well, and probably especially because it's on the more technical side too. What's been some of your better strategies for finding potential investors who really resonate with what you're building, and see very clearly like the technical advantages and value that you're bringing with Inframesh?
Yeah, well, that took a long time to kind of narrow the focus of the pitch in that way. But in terms of selling, like I try to avoid the traditional selling. As a product develops, it starts to speak for itself. The focus has always been on development and polish. Like that last 1 to 2% of polish is disproportionately expensive. But that's the difference between something that's good enough and something that people actually want to buy. So that's what I saw. And very few people want to buy the product at 98%, but when it reaches that 100%, there's no remaining friction, and that's the standard we aim for. And customers, investors notice that level of care and intent. And I think when I'm a consumer, when you feel that on a product, I just want to buy it, So one thing I'd add is don't be afraid to work with the top tier financial and legal advisors. It doesn't need to cost you necessarily something up front. I mean, sometimes VCs say, don't do that. You should do it all yourself. But for us, it really helped us get that last extra few % of polish, and it helped us to stay fully focused on the product when we were already stretched thin. What I'd say is this is an exciting AI product, and yeah, customers, investors naturally get excited about it. It's my belief that it's part of the AI revolution, and our technology will be widespread in the buildings of the future, supporting a more connected and efficient society. I think the dedication to detail, excellence, and fully solving the problem is what makes a difference, and the product's quality becomes a story instead of having to put anything else in there.
Amazing. And yeah, I think you hit a good thread there as well towards the end around the storytelling piece, because from the fundraising perspective side, there's certainly a story that the founding team or founders or whoever can tell about the company and the evolution, but the product will also tell a story on its own, as an inanimate object, but based on the value props, the way that it's been built, that tells its own story as well. And so here you can kind of have both, and it's important to have both tell a great story for you. I think that's great. And with that, we're at time. So thank you, Adam, for joining me on Bits and Atoms. It was great to have you today, and thank you again.
Thank you so much, Elias. See you around.